Flight 11 marked the finale of Starship version 2. How advanced are the preparations for version 3? New test hardware was rolled out from the Starfactory. What do we know about it? When does the Starbase Gigabay go vertical? Another company is taking a shot at developing their own lunar lander. Why is NASA picking 2 lunar rover designs? And we took a trip to ESA's technology center in the Netherlands. The owls are not what they seem. My name is Cris. Welcome to What About It? Let's dive right in. Starship updates. Flight 11 not only was a huge success, it was the end of an era. Before we close this chapter of Starship history, we have one final look back at the lead up to this important launch. Starship 38, the star of Flight 11, did have some issues, but also some exciting things. Early in the day on the 10th, SpaceX prepared and staged a ship transport stand inside of Megabay 2 where Ship 38 was being housed. 2 hours later, Ship 38 was placed atop the stand and the door was opened. But it wasn't just the Megabay door that had opened. Ship 38's payload bay door was also opened as well. Wait! It had decals. Ship 37 didn't receive its decals, but not because that was planned. The simple reason was rain. After waiting for 7 hours, the SpaceX crawler crane lifted the Starlink loading tray up to Ship 38's payload door, where crews could attach it in preparation for loading the 8 Starlink mass simulators, also known as dumplings. After waiting 9 hours with multiple workers working inside of the payload bay, the first simulator could finally be loaded at 2 AM. The process quickly picked up speed and was completed over the next 2 hours. Another 5 hours later, SpaceX closed the payload bay door on Ship 38. Now it was ready for its trip to Pad 1. With a road delay posted for noon on the 11th, Ship 38 rolled out of Megabay 2 right on time. Or so we thought. In reality, the vehicle finally began its rollout to the launch site after a 2-hour wait in the ring yard. This marked the final rollout for any version 2 vehicles. Luckily for us, the team at Redline Helicopter accommodated their schedule for us, and our photographer Jordan Guidry was able to get in the air right on time. Being able to fly during a rollout is a very special occasion for the team, as rollouts typically happen during the night and views would be limited. If you want to get an unlimited view of Starbase, the same our photographers get, go to redline.com/Felix and get $25 off for anyone using this link. The Redline Helicopter team is waiting for you. Next to Jordan, Robert Opel and Richard Gallagher were on the ground at Starbase walking alongside the ship. After the hour-long rollout, Ship 38 finally arrived at the launch site, where it would then be stacked atop Booster 15-2 in preparation for Flight 11, which, by the way, went perfect. Even during the flight preparation, SpaceX was moving around more things than just Ship 38 and Booster 15-2. A new ship test tank was recently moved out of Megabay 2. But what is this latest test tank here for? Good question. With Ship 38 and Booster 15-2 being the final version 2 flight hardware, SpaceX is in need of a brand new version. And that is just what it is working on, and in fact has been for quite a while. Developing new versions of vehicles comes with the need to validate the designs thoroughly before new flight hardware can advance to the launch pad. As seen currently with the test tanks at Massey's, SpaceX is well underway with testing the first stage vehicles, the new generation of super heavy boosters. Testing boosters is okay, but don't we need to construct test articles for the new ship generation as well? Yes, and SpaceX is doing just that. During the evening of the 24th of August, SpaceX rolled the triple ring barrel section into Megabay 2. It quickly became apparent that this would be for a brand new test tank. We know this because during ship stacking, SpaceX starts the process with the nose cone and not with a barrel section. It was also clear that this barrel was not outfitted with any tiles or clearly marked ship hardware. A few days later, on the 27th, SpaceX rolled out another 3-ring barrel. This time, it was outfitted with forward structural stringers. While testing specific things, SpaceX increases the overall structural integrity of parts they are not testing to ensure they do not fail prematurely and ruin the test results. With stringers reinforcing the forward section of the tank, we can safely assume that SpaceX is looking to test the new version 3 ship aft design. But there is an issue. So far with this new version of ships, we have only seen one development test of this aft section. This single aft was seen rolling out of the Starfactory, upside down. And then it was unceremoniously moved to the scrapyard. With this aft testing barrel moved to the scrapyard, we can safely assume that SpaceX was not yet ready to enter testing with the new version's aft design. During the day of the 11th of this month, SpaceX lifted these 6 rings to a ring stand that was staged inside of Megabay 2. Where could they be going? The only logical place would be back to the factory. And SpaceX did just that. Later during the night, this test tank was rolled back into Starfactory. We suspect this was so it can receive its aft and furthermore clear the turntable in the bay. And a clear table also means enough space for Ship 39 stacking. In the past few months, the Starbase community has been tracking the production of Ship 39, the first version 3 ship. With limited views, it has been hard but doable. Let's track back to the beginning. In April, Jack Beyer with NASA Spaceflight posted on X with a picture of a LOX header tank. A header is what supports the landing burn of a ship due to the low propellant levels following the ascent burn. SpaceX has chosen to put it in 2 separate tanks, one for liquid methane and one for liquid oxygen. The liquid oxygen header is what sits at the very top of the nose cone, with the liquid methane header just below it. But before we talk about what this entails, hit the subscribe button to stay informed. Like this video if it brought you value, and consider becoming a wise supporter for extra content. Up to 7 picture galleries per week, satellite, helicopter, ground photos and 3D animations. Chat with us and gain more insights on the topics you love. Thank you very much. In another photo from Jack in the same post, we can confirm that this is Ship 39's LOX header. Woohoo! Moving a few months down the line in July, Starship Gazer posted on X giving us the next view of Ship 39. In Starship Gazer's image, we can see that Ship 39 had its nose cone sleeved over both header tanks and had thermal protection tile pins installed. These pins are what hold the iconic heat tiles in place. Toward the end of July, Starship Gazer once again posted on X, showing that Ship 39 had one of its 2 forward flaps installed. So far so good. Just 2 days later, another picture was posted showing a second forward flap and the black ablative layer that sits under the TPS tiles getting installed. 2 days. Yes, SpaceX does move quickly. 16 days later, Starship Gazer posted another picture of Ship 39. This time stacked atop its payload bay. We can tell it was stacked atop its payload bay because it is sitting higher in the windows than it was before. The payload bay adds an additional 3 rings and is able to be stacked in the Starfactory. This started with Ship 36. Stacking inside the Starfactory guarantees that SpaceX can do all the necessary work prior to rolling out the first major section of a new ship. Over the span of a few months, Lab StriX has gotten continuous views of Ship 39 and its progress. More recently, scaffolding has been slowly getting removed from the ship nose cone and payload bay, indicating that a rollout could happen very soon. And it did. On the 12th, SpaceX rolled out the pass dispenser for Ship 39. The pass dispenser is the mechanism that holds and deploys the Starlings during flight. Upon a quick inspection, it remains unclear what changes SpaceX has made, but it is safe to assume that they have made some. We expect Ship 39 will not carry real Starlings yet. It will fly on a suborbital trajectory first, as it is a brand new version of ship. There will not be any orbital flights before version 3 is fully validated. Finally, in the early morning of the 13th, Ship 39's beautiful nose cone was rolled out. This new nose cone design features visible docking hardware, new catch pins and a very clean looking heat shield. We will take a deeper look at these changes very soon. Let's move on to the construction site of the giant future integration building. The Gigabay at Starbase is finally starting to take shape. On the 7th of this month, during the late afternoon, the final pile cap concrete pour started. This is the concrete that will support the entire weight of the bay, so they need to ensure these pours are perfect. This concrete pour, being one of the final foundation pours, means that the Starbase Gigabay can finally start to go vertical. Just 2 days later, the first of many tower crane segments arrived at the site, and it was soon installed in its rightful location, from where it will complete 1/4 of the bay. That's right, only a quarter of the bay. It is clear that SpaceX will need a few more tower cranes to assist in the assembly of this bay. This building will be of truly titanic proportions. NASA is approaching a pivotal decision point in its quest to return astronauts to the moon, and there's growing speculation that the space agency might select not just one, but 2 companies to build the next generation lunar terrain vehicle for the Artemis program. NASA asked the 3 competing teams to present 2 separate plans, one covering the full development through operational deployment on the moon, and another stopping at a critical design review. This dual request structure positions NASA to potentially select 2 winners from the competition. This choice would provide redundancy and reduce risk for the critical Artemis missions. The House Appropriations Committee has approved the fiscal 2026 appropriations bill for NASA. As part of this approval, lawmakers included reporting language that encourages NASA to choose at least 2 providers for lunar terrain vehicles. From a government perspective, awarding 2 contracts feels prudent, as it protects against relying on a single contractor who could potentially drop out. Better not put all of your eggs into one basket. NASA selected 3 companies in April 2024 for year-long feasibility studies, each bringing unique approaches and capabilities to the competition. The total contract has a combined maximum potential value of $4.6 billion for all awards. But who are these 3 contenders and how far advanced are the research and development of their respective LTVs? Houston-based Intuitive Machines leads the Moon Reusable Autonomous Crewed Exploration Rover, or RACER team. Please keep these horns on the hood. Intuitive Machines rover is developed in partnership with AVL, Boeing, Michelin and Northrop Grumman. The Moon RACER is designed as a pickup truck-sized vehicle that can carry 2 astronauts wearing spacesuits plus 400 kilograms of cargo, with the additional ability to pull a trailer loaded with 800 kilograms. It can reach speeds up to 15 kilometers an hour, traverse slopes up to 20 degrees, and clear obstacles up to about 30 centimeters high. Colorado-based Lunar Output leads the Lunar Dawn team, with partners including General Motors, Goodyear, MDA Space and Leidos. Their rover Eagle features a reconfigurable cargo bed and a robotic arm for handling payloads, relying on autonomous navigation software. Their vehicle has undergone extensive field testing at Lunar Outpost's 4 square kilometer testing facility in southern Colorado. Lunar Outpost has unveiled its 4th vehicle-level prototype in less than 12 months at Space Symposium 2025. The company has also already signed an agreement with SpaceX to use Starship to deliver the Eagle to the Moon. California-based Venturi Astrolabs leads the FLEX team with partners Axiom Space and Odyssey Space Research. FLEX in this case is short for Flexible Logistics and Exploration. With a maximum combined rover and cargo mass of more than 2 tons, the FLEX rover is nearly 3 times the mass of its largest predecessor. The vehicle features hyper-deformable wheels and specialized batteries developed by partner Venturi Space to handle the extreme conditions at the lunar South Pole. All 3 LTV bidders suggest that beyond NASA contracts, they can work with companies who want to prospect for resources, build launch pads and roads, do quantum computing and set up infrastructure to sell services to the government. The coming month will be crucial as NASA evaluates the 3 comprehensive proposals. Whether the agency selects 1 or 2 providers, the decision will shape lunar surface operations for the next decade. I am beyond excited to see a brand new breed of lunar rovers in action soon. Now it's time to go down under to New Zealand. Rocket Lab launched its all-new World mission on Tuesday, deploying a single StriX satellite to a 583-kilometer low Earth orbit from the company's Launch Complex 1 in New Zealand. The mission was Rocket Lab's 7th launch for Japanese company since Spactive, and there will be 21 more missions to complete the company's Earth imaging constellation before the end of the decade. The StriX satellite is a small, innovative synthetic aperture radar or SAR spacecraft, weighing in at approximately 100 kilograms. Its small footprint is the real innovation in StriX. It is about 1/10 of the size of conventional large SAR satellites. Okay, I got that, but what's up with the owls? It's all in the name. The satellite is named after Strix uralensis, the scientific name for owls. The satellite shares the bird's ability to see in the dark, as SAR technology can image Earth's surface day or night regardless of weather conditions. Their mission will provide high-frequency, high-resolution Earth observation data for disaster response and management, national security and environmental monitoring. A StriX satellite can capture images with a ground resolution of 1 to 3 meters and its swath is 10 to 30 kilometers in width. Its design features a deployable parallel plate slot antenna composed of 7 independent panels. Before launch, it measures approximately 80 centimeters on each side as a cube and then deploys in orbit. Equipped with a high-output 1 kilowatt amplifier and advanced thermal control, the satellite achieves imaging capabilities comparable to much larger SAR satellites at approximately 1/20th the cost. The launch represents Rocket Lab's 15th mission of 2025 and 73rd overall, maintaining a 100% success rate for all missions this year. Good job, Rocket Lab! Leaving beautiful New Zealand behind, we head over to Europe. Celebrating its 50-year anniversary, ESA opened the doors to its technology center in the Netherlands, and we were happy to follow this invitation. After previously reporting on Plato's arrival, it was amazing to see this huge satellite in person. What an impressive feat of engineering. Over 800 scientists and helpers volunteered to not only give visitors a chance to look inside their Aztec facilities, but they were also willing and happy to explain their projects and innovations to interested visitors. One technology ESA is working on are systems for lunar resource harvesting. One of the most promising technologies in this regard is electrolysis, that is using electrical power to split lunar soil called regolith into its separate ingredients. This will one day enable independent lunar fabrication that will not require materials to be sent up from Earth. Engineers showed and explained how satellite subsystems like gyroscopic stabilization or payload separation systems work. This is one of the rare times when spaceflight enthusiasts can come close to real hardware and get a much better understanding of the intricacy of these technological marvels. In some cases, you can even touch items to give you a better feel of just how sophisticated, lightweight and almost magical spaceflight hardware truly can be. Prototyping has been supercharged by 3D printing, giving scientists a lot more freedom to turn their ideas into physical prototypes for further research. By now, 3D printing has already matured to become a manufacturing technology that is widely used in the space industry. Fascinating hands-on demonstrations are a great way to inspire visitors of all ages. We are very happy that ESA does open their doors to the public once a year, and we can highly recommend visiting these events. Thank you, ESA. Now let's leave the Netherlands behind and hop over to the US West Coast. Momentus, a California-based commercial space company, has secured 2 significant contracts with NASA, marking a major expansion of the collaborative relationship. The company specializes in providing in-space transportation and infrastructure services. It operates satellites and spacecrafts that can transport payloads between different orbits, offer hosting services for customer payloads, and conduct various in-space operations. Their signature technology includes water-based propulsion systems which use superheated water vapor as a propellant. This very interesting approach might become a safer and more environmentally friendly alternative to traditional chemical propulsion. Momentus calls this fascinating propulsion technology the microwave electrothermal thruster, also known as MET. Engage water drive. Unlike conventional chemical rockets that rely on toxic and explosive fuels, this system superheats water into high-temperature plasma using microwave energy and then expels it to generate thrust. NASA has recently shown confidence in Momentus' capabilities to push the boundaries of space technology by awarding 2 significant contracts totaling $7.6 million. The first contract is enabling a demonstration of in-space manufacturing. This demo will explore technology for producing materials and components directly on orbit. Manufacturing in the microgravity environment of space offers unique advantages, including the ability to create materials with properties impossible to achieve on Earth. In the second demonstration, Momentus will showcase another innovative propulsion technology, one which could provide more efficient and cost-effective methods for moving spacecraft and payloads throughout the solar system. A compact RDRE, or rotary detonation engine. Regular watchers will remember that we recently covered another company working on this propulsion solution, Venus Aerospace. Now we can report that this idea proves promising enough to have multiple companies taking a shot at it. Advanced propulsion systems are crucial for future deep space missions and the establishment of sustainable space operations, and RDRE might just be one of these enabling technologies. We stay in sunny California and have a look at Impulse Space. This self-proclaimed in-space transportation company, founded by former SpaceX propulsion chief Tom Miller, has unveiled ambitious plans to develop a lunar lander. The new craft is planned to be capable of delivering up to 3 metric tons of cargo to the moon's surface starting in 2028. The announcement positions the company to fill what Muller describes as a critical gap in lunar cargo delivery capabilities. The proposed system combines Impulse's upcoming Helios transfer vehicle with a newly designed lunar lander, both developed in-house. Under this architecture, the lander would launch aboard a standard rocket and deploy in low Earth orbit alongside Helios. The Helios kick stage would then transport the lander to low lunar orbit within approximately 1 week, after which the 2 vehicles separate and the lander descends to the surface. Notably, the design eliminates the need for in-space refueling, a complex requirement that challenges many competitors. Impulse argues that current lunar delivery options leave a significant capability void. NASA's Commercial Lunar Payload Services program primarily handles smaller payloads, while human landing systems under development target much larger masses for crewed missions. The company's 3-ton capacity targets the middle range. It is ideal for rovers, habitat modules, power systems and communication equipment essential for building lunar infrastructure. With Helios scheduled for its first flight in late 2026, Impulse estimates it can deliver up to 6 tons of payload to the moon across 2 missions annually by 2028. And that wraps it up for today. Smash that like button, subscribe for more. This is what fuels the algorithm, and this is how you can help us for free. Check out our epic shirts in your favorite Space Nerd store. Our brand new Mechazilla shirt is up. The link is in the description and in the card you should see on screen right now. How does SpaceX's Raptor 3 engine work? Watch here to continue your journey. Up to the ship 38's pad. The payload board. Stack it inside of the factory.